Hello everyone, welcome to the Water Pollution Control Technology classroom. Today we will learn about anaerobic digestion of sludge together. Anaerobic digestion of sludge and organic matter in sludge. Under anaerobic conditions, anaerobic microbiota, the process of final decomposition into methane and carbon dioxide. It is currently the most commonly used sludge biological treatment methods internationally. It is also a large sewage treatment plant, the most economical method for sludge treatment. So before understanding anaerobic digestion of sludge, it is necessary for us to understand the principle of anaerobic digestion of sludge and organic matter decomposition. Let's first take a look at anaerobic digestion of sludge. It is a multi-stage complex process. The complete digestion process requires 3 stages. Currently recognized 3 stages. The hydrolysis and acidification stages are respectively acetation stage. There is also a methanation stage. The 3 stages are both interconnected and influenced by each other. Each stage has its own unique microbial community. For example, the first stage, general hydrolysis process, occurring in the initial stage of anaerobic digestion of sludge. At this time, non-water soluble polymer organic compounds in sludge, such as carbohydrates, proteins, fats, cellulose, etc., under the action of microbial hydrolytic enzymes, hydrolyze into soluble substances. What about the substances after hydrolysis? Under the action of facultative and anaerobic bacteria, transformed into short-chain fatty acids. For example, acetic acid, propionic acid, butyric acid, etc. So there's also ethanol and carbon dioxide. What about the second stage? This stage is mainly composed of acetic acid bacteria, hydrolysis and acidification products, organic matter, ethanol, etc., convert to acetic acid. So in this process, acetic acid bacteria and methane bacteria are symbiotic. The third stage is the methanation stage. It mainly occurs in the later stage of anaerobic digestion of sludge. During this process, methane bacteria combine acetic acid and hydrogen gas, separate conversion of carbon dioxide into methane. Secondly, let's take a look at the anaerobic decomposition of organic matter. In general, organic matter present in the animal and plant kingdom. It can be roughly divided into 3 categories: carbohydrates, fats, and proteins. So the anaerobic digestion process of these 3 types of organic substrates, it's probably like this. The first is the anaerobic decomposition of carbohydrates. Carbohydrates are first activated by extracellular enzymes, hydrolyze into monosaccharides, and then infiltrate into the cells, under the action of intracellular enzymes, transformed into alcohols such as ethanol and acids such as acetic acid. The second is the anaerobic decomposition of fat. So fat hydrolyzes into fatty acids and glycerol. The third is the anaerobic decomposition of proteins. At this stage, the breakdown of large molecules in proteins into simple main components. Next, let's learn more about it. Factors affecting anaerobic digestion. So there are many factors that affect it. The first one is temperature. During anaerobic digestion process, we can control the temperature at low temperatures. 3 situations of moderate to high temperature. Low temperature does not control digestion temperature. The high temperature is usually 50 to 55 degrees Celsius. The second influencing factor is pH value. Hydrolysis to ferment bacteria and hydrogen-producing acetic acid bacteria. The suitable pH range is 5.0 to 6.5. Methane bacteria. The suitable pH range is 7.3–8.0. If reaction rate of hydrolysis acidification and acetic acid process exceeding the rate of methanation process, pH will decrease, thereby affecting the living environment of methane-producing bacteria, and then, it will also affect the effectiveness of anaerobic digestion of sludge. The third influencing factor is nutrition to carbon-nitrogen ratio. The most important thing is the carbon-to-nitrogen ratio. Carbon-to-nitrogen ratio too high, insufficient nitrogen content of bacteria, reduced buffer capacity of digestive fluid, pH value is prone to decrease, but if the carbon to nitrogen ratio is too low, the nitrogen content is too high, the pH value may rise above 8.0. The ammonia salts of fatty acids will accumulate, so the decomposition of organic matter is inhibited. The fourth impact is the type of sludge. We know, the sludge in the initial sedimentation tank is rich in nutrients, easily digested by anaerobic digestion, large amount of gas generation, residual sludge from secondary sedimentation tank, mainly composed of aerobic bacteria, so the decomposition speed of organic matter decomposition particles is slow, less gas generation. The fifth is the dosing rate of this sludge. Generally speaking, increase in dosing rate, the degree of decomposition of organic matter will decrease, decreased gas production, but the required volume of the digestion tank is small, the allocation rate has decreased, high degree of decomposition of organic manure in sludge, increased gas production, but the required volume of the digestion tank is large, high infrastructure costs. The sixth one is stirring. Stirring during anaerobic digestion, not only can it make the head grow sludge, uniform contact with mature sludge, accelerated conduction, methane and hydrogen sulfide produced by biochemical reactions, gases that hinder anaerobic active bases, driving it out also helps to crush the mud blocks, and the floating debris layer on the leaf surface of the nitrification tank, enhancing the role of nitrification pool recombination. Stir thoroughly and evenly, it is the key to the stable operation of the sludge digestion tank. The seventh is the inoculation of sludge. Inoculated sludge should contain as much as possible alkaline anaerobic bacteria required during digestion process, and acidic anaerobic bacteria. Furthermore, it is best to use nitrifying sludge with fewer harmful metabolites. Good inoculation sludge, mostly present at the bottom of the final digestion tank. 8 is the content of toxic substances. When toxic substances are present in sludge, for example, heavy metal surfactants, so these substances will digest the sludge. The impact of composting and other factors. Next, let's learn about the anaerobic digestion process. At present, widely used anaerobic digestion process, mainly divided into three categories. There are standard digestion methods, rapid anaerobic digestion method and secondary anaerobic digestion method. The standard anaerobic nitrification method, also known as primary digestion, its principle is shown in the figure. Rapid digestion method. The biggest difference from the standard digestion method is, there is no mixing device in the pool, its mixing is relatively uniform, very good operational performance. Secondary digestion method. It is first digested in a primary digester, then, the discharged sludge is sent to the second stage digestion tank. The fourth aspect. Let's take a look at the operation and management of the digestion tank again. So the content of this section mainly includes cultivation and domestication of digestive sludge, and daily maintenance of the digestion tank. There are two main methods for cultivating and treating digested sludge. One is the gradual cultivation method. Gradual cultivation. It refers to the daily discharge of primary sludge and concentrated sludge, input into digestion tank, then heat it up. Increase the temperature by 1 degree Celsius per hour. When the temperature rises to digestion temperature, maintain temperature constant. Then add fresh sludge day by day. Stop adding mud until the design liquid level is reached. Continue to maintain digestion temperature. Hydrolyze and liquefy organic matter. This time will take approximately 30 to 40 days. After the sludge matures and produces biogas, only then can it be put into normal operation. And the one-step cultivation method. It is the process of converting coarse sludge into concentrated sludge, put into the digestion tank. The dosage accounts for 1/10 of the solvent in the digestion tank. In the future, add fresh sludge daily to the design liquid level, then heat it up. Control the heating rate by 1 degree Celsius per hour, finally reaching digestion temperature. Produce biogas after 3 to 5 days of sludge stabilization, then add fresh sludge. Daily maintenance of digestion tanks, mainly including the following content: sampling analysis, cleaning and slag removal, maintenance of the mixing system, maintenance of heating system and structure of digestive system, inspection and handling of digestion tank shutdown, digester foam control, so there's also insulation for the digestive system, safe operation. The above is the content of this study. Thank you.